Today's lesson, we are going to be discussing stem and leaf plots. And it's just a different way to organize data. We've been talking about visualizing how data is set up, and this is another way to do it. A stem and leaf plot is used, it's going to organize a lot of points in a table to kind of make things a little easier to see, specifically the spread of the data. So you can see where most of the data lies. It kind of organizes it into groups. So each value is broken apart into a stem, which typically represents the first digit of a value, sometimes the first two digits of a value if they're in the hundreds or the thousands, and a leaf, which typically represents the last digit of the value. Okay, the stem and leaf plot below here, or well, actually on the side here, is going to show the heart rates of students who had done jumping jacks for 1 minute. Now, the way this is displayed, it's kind of a little bit unclear how this works out, but the stem is going to show a tens position and the leaf is going to be your ones position. And I know that because the key down here tells me so. So 6 on the left in the stem column and a 1 on the right in the leaf column represents 61. So that means I have a 61 here. In the 70 range, I don't have any numbers in the 70s. There's nothing there. Then I have an 84, an 86, and an 88 here for the 80s. For the 90s, I have a 92 and I have 3 99s. I don't have anything in the 100s. The 11 stem with a 3 leaf is going to give me 113. And then subsequently the 114. Oh, we got a lot in the 120s. So we have 121, 122, 124, another 124, a 127, and a 129. We have a 138, we have a 144, a 147, and a 148, and we have a 151. So it's just a way to organize your data. All right. We have to find the mean, the median, and the mode, so that way we can, or the mean and the median, excuse me, so we can compare them to answer part A. The mode is part B, and we're going to do exactly what we did before. It's just the data is given to us in a different way. Okay, so your mean is your average. I'm going to add everything up. I'm going to get 2,410 divided by 2. So my average is 114.76. And my median, when I line this up, so the one way to look at finding the median here is to kind of count and cross off numbers the way I showed you the other day. 61 is your smallest number. 151 is your largest. So if I cross off the smallest and the largest and continue to do that going up in order, you will eventually cross everything off until you get down to either 1 or 2 numbers, depending. And then we know how to find the median from there. Or you could line up your numbers. You can write them all out like I did before and line them all up and do what you got to do that way. Or you can just do it right here in the table. Okay, so then I'm going to cross off the next biggest, which is an 84, the next largest, which is a 148. So do you see how I'm kind of crossing off the next? So 92 would be the next one, and 138 is going to be your biggest. Then now 99 is next, and 129. So I'm working from both ends here until I can get down to a single number. So the median is going to be 121. Okay, so that's how I do this on a stem and leaf. Again, if that didn't make a whole lot of sense, you could just write all these numbers out in a list. Okay, so to answer the question, which of the following is true? The median is larger than the mean, or the mean is smaller than the median. So the answer is letter C. The mode, which number occurs most often? That's going to be your 99. Okay, so what is the lowest heart rate? That's going to be a 61. In which interval did most heart rates fall? Well, that's this guy right here in the 120s. So from 120 to 129, that's going to be where the most heart rates fell. How many students were in the class? You're going to add up, or you're going to count up how many data points there are. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There were 21 students in there. And last part, how many students had heart rates lower than 90 beats per minute? So lower than 90 is going to be anywhere in this range here. So there are 4 students. Okay, so that is a single stem and leaf plot. Now you can have also back-to-back stem and leaf plots that represents two data entries, two sets of data using the same stem. Okay, so in fundraiser sales, we're showing data sets for the 9th and 10th grade fundraiser sales. So my 9th graders over here, this is in dollar amounts. So we have a 55. So I'm going to line this up over here. We have a 55. We have a 65. And we have a 67. Remember, this is your stem. Your stem represents your tens place. Okay. Then you have a 73, a 74, and a 77. Notice it goes from the center out. Okay. And then we have an 81. We have 2 83s. We have an 85. And we have an 86. For our 10th grade sales, we're going to look at the same data. And hey, where's that color I want? There it is. We're going to look at the same data. There's nothing in the 50s for the 10th graders, but they have a 66. A classroom got 66. We have 68. We have a 69. We have a 70. We have a 72. 2 75s. We have a 77. We have a 79. We also have an 83. Okay, so that's going to be my 10th grade data. So now it's just two groups of data displayed on the same stem and leaf chart. That's it. Okay. So it says, what is the median of the 9th grade fundraiser sales? So what's the middle number in your 9th grade fundraiser? Well, you can cross them off from the smallest to the biggest, and you just cross off the next smallest and the next biggest and the next smallest and the next biggest and the next smallest and the next biggest and the next smallest and the next biggest, and it's a 77. 77 is left. That's your one in the middle. So we got a 77. Okay, so there's the answer to that one. So the math that we're doing is the same as what we've been doing. It's just displayed in a different way. Letter B, it says, what is the range of the 10th grade fundraiser sales? So that means I'm looking at 10th grade, and range is going to be your max minus your min. So that's going to be 83 minus 66. 83 minus 66 is going to give me 17 is my range. Then it asks me to find the mean of all of the fundraiser sales. So that means I have to add up all of the numbers and then divide by the total. So how many total do I have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 9th grade homerooms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 10th grades. So that means I have 21 total homerooms. And when I do that, I'm going to get 1563 divided by 21 when I add them all up. And I get 74.43. And that should make sense because this is a dollar amount. Okay, so we're talking about money here. So that should actually make some sense. Okay, on the next page, we have another stem and leaf plot talking about car miles per gallon. We're talking about gas mileage. So the stem and leaf plot below shows the new car gas mileage of cars on city versus highway. So when you buy a car, there's a lot of data that comes along with the car, one of which is how many miles per gallon it gets driving on the highway versus driving in the city. When you're driving on the highway, you get better gas mileage because you're not stopping and going. The stopping and acceleration accelerating specifically burns more gas than staying at a constant rate of speed. So it's asking us to do a couple of things here. It says, compare the gas mileage of the cars from city to highway. Which data is closer together? So what exactly am I supposed to do with this? Which data is closer together? That is asking you something that you already know how to do, just in a different way. It's asking for which range is the smallest. So which range is the smallest? Okay, so that's what we have to find. We got to figure out the range of both of these things. Okay, so let's take a look at city on the left. So the best gas mileage they get on the city So we have a 19, we have a 20, a 23, a 23, a 28, a 29, a 31, a 31, a 34, and nothing in the 40s. So the best gas mileage in the city is going to be a 34. Minus, what's the smallest gas range in the city, is going to be a 19 miles per gallon. So that means in the city, 15 miles per gallon is the range. Okay. So on the highway, I'm going to do the same thing. The best gas mileage is 41 miles a gallon. The smallest is 27 because that's the smallest number on the right side of my stem and leaf plot. So 41 minus 27 is going to give me 14 miles per gallon. So it asks which data is closer together, which range is the smallest, which span is the shortest. The answer is your highway. Okay, it's the highway because it's the smallest range. That means the numbers are the closest together between the two of them. Okay, letter B. Compare the gas mileage of the cars from the city to the highway. Better gas mileage occurs when you can go more miles per gallon, thus the larger numbers. Does the city or highway have better gas mileage? So what we're going to do is we're going to find the average of these things and we're going to compare them. Okay, so let's find the mean of the city. So I'm going to add up all of my numbers on the left side of my stem and leaf plot. So I'm going to add the 19, the 20, the 23, the 23, the 28, the 29, the 31. This is weird because you're looking at the stem first and then looking to the left for the leaf. So make sure that you're understanding where these are coming from. Okay, so we're going to add all of those up. And when we do, we get 238 divided by, there are 9 cars. Okay, so we're going to divide by 9. The mean for this guy is 26.4 repeating miles per gallon. Okay, great. Now I'm going to do the same thing for the highway. So for your highway, I'm going to add up all of the miles per gallon, and then I'm going to divide by 9 because there are 9 here. So I'm going to get 303 when I add, whoops, that's not 303. 303 when I add them all up, divided by 9. And that is going to give me a 33.6 miles per gallon. So not per hour, per gallon. There we go. So does the city or the highway have better gas mileage? To no surprise to anybody, it is your highway. I explained to you a minute ago, I can't spell and talk at the same time. Highway. There we are. You know, practically speaking, when you're driving at a constant rate of speed, it uses less gasoline than it does when you start and stop and start and stop and start and stop. The constant stopping and then acceleration from standstill burns more gas than just staying at a constant speed. So that makes sense. What is the lowest gas mileage for highway? So you're going to look up at your chart and you're going to go, okay, well, what is the lowest number? So I'm ignoring all of these things for this particular question. So on the highway, what is the lowest? It's going to be a 27. It's 27 miles per gallon. Okay. The next question says, what is the highest gas mileage for the city? So I'm flipping over to the city side of this. I am ignoring the highway. Okay. What is the highest gas mileage for the city? Well, that's going to be a 34. Stem of 3, leaf of 4. That's going to be a 34. So 34 miles per gallon. And then it's asking how many cars were recorded for the gas mileage. And in this case, there were 18. They had 9 cars recorded for city and 9 cars recorded for highway. Although, or one could argue that it was 9 cars and they just figured out the miles per gallon for each of the 9 cars in the city and also the highway. So it could be 9 cars. I could take either one of those answers because you could argue it either way. Okay. So what I would like for you to do is on the first day of this, I would like for you to do 8 to 14. Okay. I should be 1. It should start at 1. The numbers got messed up. It's fine. But these questions right here that go along, it says answers 1 to 6, but it's actually 8 to 14. So do this first part today. And then we'll do this one next class. So from 15 to 22 next class, okay? Thank you very much. I appreciate your attention and have a great rest of your day.